Dear students, this is Dr. Biju Vasudevan. In this video, we will discuss the topic 9.8 line integrals, which follows week 7 as per the regular semester system. Okay, let us see the introduction to line integrals. The notion of the definite integral a to b f of x dx. This integration of a function defined over an interval can be generalized into integration of a function defined along a curve. So to this end, we need some terminology about the curves. So some important terminology about curves. C is a curve parameterized by x is equal to f of t, y is equal to f of t, t. So for example, if you have a curve x square plus y square is equal to r square, you can write parametric form x is equal to r cosine t, y is equal to r sine t. This is the parametric form of the curve, isn't it? For example, if you have y square is equal to 4x, you can write x is equal to 2at, x is equal to 8t square, y is equal to 2at. So when you substitute both here, y square is 4a square t square. On the right side it will be x is equal to 8t square. So 4a square t square, isn't it? They are equal. This is the parametric form of the parabola of this type. So that is given here, parametric form f of t, x is equal to f of t, y is equal to g of t, where t is between a and b of the curve, isn't it? A and b are endpoints. A and b are endpoints given here respectively. Then we say C is smooth curve. Smooth curve. What is the smooth curve? There's no other kind of. See, this is the example of smooth curve. Here it is piece. This part is smooth. This part is smooth. Altogether, it's not a smooth curve here. Parts are smooth. It's called piecewise smooth curve. This is closed but not simple because there are two regions. This is closed and simple. So here we can now read the definitions. Smooth curve. C is a smooth curve if both the first derivatives are continuous on the closed interval and not simultaneously zero. Both are not zero in the interval, isn't it? In the interval. So here the interval is a and b. In this interval, the first derivatives f and g functions differentiable. Okay. C is piecewise smooth if it consists of finite number of smooth curves and the curve is a union of all the parts. C is closed if end points are same. C is simple closed, the curve does not cross itself. Sometimes see here in this curve they cross each other, so this is not simple. And if C is not closed curve, then the the positive direction of on C is the direction corresponding to increasing values of t. Okay, these are some basic terminology about the curves. Now, definite integral, similar like our Riemann sum, the definition has been given like resembling the Riemann sum of the dimension relation, but we write a different form of line integral here along every direction. Okay? Before defining integration along the curve, let us review first 5 steps leading to the definition of a definite integral. Just refer your calculus. Now let's be back. But here, same concept. See, but here this is the curve, isn't it? Curve from this is the curve from a to b direction. There are n parts, and we are taking some point here xk, yk. In this direction, the change is del x. In this direction, the change is del y. And there is another direction here, it is del s along the curve. And remember, in this there will be a relation between it, will be looking like a triangle in the very small part. When you consider a small part of the curve, this del x, del y and del s looking like a triangle. Therefore we can write by Pythagoras theorem del s is nothing but square root of del x whole square plus del y whole square. This rule is necessary for further derivations. Okay. Now line integrals in a plane. The following analogs 5 steps to the definitions of the 3 line integrals in a plane. See, let z is a function of x and y is defined in some region that contains the smooth curve C. Some region that contains, so it's a function is defined somewhere in the region. This region contains the smooth curve C, right? Now divide C into n sub arcs of length del sk according to the partition. So you get this one. Initial and end points are A and B. Let the projection of the sub arc into the x and y axis. So this is the small part, isn't it? Del you can say this part is okay. Its projection on the x axis is del x. Its projection on the y axis is del y. This part can be anything. Del c1 tk plus 1 is possible, isn't it? In this interval. So its projection on x axis is del x, y axis is del y. Del y k, del x k, del y k. Okay. Now P is the norm of the partition. I mean the length of this partition. P is the norm of the partition, or the length of the longest sub arc. Assuming that the arc we have taken, the sub part we have taken is the longest one, and we take a sample point on this arc called x star, k star, and now let's form the Riemann sum. 3 different Riemann sums. This is for g of xk. In this g of xy, g of xy, substitute x and y, xk star, yk star, and multiply with the del xk. So another one is, and sum all the parts, multiply, substitute the xk star, yk star in g of xy, and then multiply with the del yk. Third sum we are forming in the direction of del s. So now we are forming 3 summations, one for del x, another one for del y, another one for del s. Now the line integrals along in the plane along the curve, isn't it? Let G be the function of 2 variables defined in the region containing the curve, smooth curve C. Now what is the definition of line integral? What is the line integral of G? G is the function of xy on the plane. And now along C we have to integrate from A to B. Isn't it? So this is the curve C. From A to B we are integrating the function f g of x comma y along this one. First one with respect to x, second one with respect to y, third one with respect to s. This is what given. So when you take the longest length into 0, there will be infinite number of parts. So it resembles Riemann sum, isn't it? This is for dx, this is for dy, this is for dz. We are not going to use these definitions. We have a different formula to find this line integrals. Is coming up. Method of evaluation. So what is the way to find integral along C, g of xy dx? What we got to do? We know that x is f of t, y is f of t, g of t, isn't it? So differentiate, substitute wherever x comes, substitute f of t, wherever y comes, substitute g of t, wherever dx comes, differentiate this one. It will be f dash of t into dt. That's it. So dx will be replaced by f dash of t into dt. Similarly, dy will be replaced by g dash of t dt. And we will substitute wherever x comes, we will replace it by x of t, f of t, y will be replaced by g of t. For ds, by the Pythagoras theorem, we know that ds is square x prime, isn't it? X dash ds. We know that del s is del x square plus del y square. So what is ds? Dx square plus dy square. When you substitute dx is f dash of t dt. So you will get this formula for ds. Why? Because ds is x dash is f dash of t dt whole square plus y dash g dash of t dt whole square. So take dt square common and take square root of it will be dt. So under square root it is f dash of f dash square plus g dash square. This is what given here. So only these three formulas are necessary for solving evaluating a function of two variables. Now the same can be extended for three variables. That is given here for this is the formula we are using for explicit function. When y is given as a, instead of giving y is equal to f of x, when you get an explicit function, we use these three formulas. Dx will be dx, and dy will be f dash of x into dx. And we have to find y is equal to function of x. Then we will find substitute y dy dash of x, and now ds will become 1 over f dash of x whole square dx. In the formula you can refer this one. This can be proved if you change instead of parametric form. If you take y is equal to y dash is f dash of x, isn't it? And third one is this ds along if a line integral along a piecewise smooth curve C defined as the sum of line integrals. So if there are piecewise curves here and we want to integrate along all the curves, integrate along C1, integrate along C2, along C3, and then sum them up. That is given here. So in many applications, line integrals appear as sum. P of xy dx, P of q of xy dy. So we don't need to, we can directly write them without using bracket. We can write them. That's the concept. So integral p dx or plus integral plus q dy means integration is for both the terms. We don't need to use brackets there, parentheses there. That's the concept. So you can you try how you get this one, isn't it, for ds, because x both sides you will get x, isn't it? What is it? Instead of x of t, x is x, y is equal to f of x. Then what happens? For dx by dt it will be 1, dy by dt will be y dash square and dx square, isn't it? You can simply, very simple this one is. So we don't want the derivation, you can find it. Now line integral in three space, three function of three variables. Just extend the concept for one more variable. G of x comma y comma z. X is replaced by f of t, y is replaced by g of t, z is replaced by h of t, and now dz, one more time, h, because z is h of t, therefore dz is h dash of t and d of t. One more time adds, isn't it? And dz will be a combination of three variables now, f dash square, g dash square, and h dash square, just like the same method of, yes. Okay, that's it. Now some information about work done. The formula, if f of x is given as force vector, and then when you integrate from a to b along dx with respect to x, it will be we are calculating work. So some explanation has been given. Check what work. Okay, just straight away. So this is the formula, f dot dr will give you the work. Okay, if f is not a force, if f is a velocity, then f dot dr is not work done. It's circulation of f around the curve. So when you integrate f dot dr, if f is given as velocity, it will give circulation. If f is given as force, it will give work done. Otherwise, just you are evaluating a function over the curve. Now let us start exercises. Okay, you should remember this exercises, the method to evaluate them. There are three integrals. See, all the three will be giving you different answers. They won't give the same answer. So they are different integrals, right? It's not, we are not finding area under the curve, it is different. Okay, this is function of two variable and you are converting to one variable in parametric form and then integrating. Okay, let's start first case for problem number 1. First case, what is it? Integral over c. What is the curve? Curve is given here in parametric form. A circle, isn't it? X is equal to 5 cosine t, y is equal to 5 sin t, and t is from 0 to pi by 4 I, right? So integral c g of x comma y dx, isn't it? Now, well, let us write first part of question number 1. G of x comma y is integral to xy. What is x? 5 cosine t, y 5 sin t, and then dx. Differentiate x, what do you get? 5 is constant. When you differentiate cosine, is negative sin t dt. So dx is negative 5 sin t dt, and the limit of everything is a function of t now. So one variable integration now, isn't it? This is 0 to pi over 4. 0 to pi over 4. What is that? On the next step, see, we are doing only with respect to x, this part. What is the constant? 2 times 5 into 5 into 5, negative 5, 125 into 2, 150, 250, isn't it? 250 with a negative sign. Now sin square integral 0 to pi over 4 sin square t and a cosine t dt. Now you can use a substitution method. To further integrate this one. Let u is sin t, then du will be cosine t dt. So what happens further when you integrate this one? This negative 250 stays outside. 0 to pi over 4 sin square is u square, cosine t dt will be du. So negative 250, when you integrate u square, it will be u cube over 3 from 0 to pi over 4. I'm just showing here. So negative 250 over 3, isn't it? U cube. In u cube, what is u? Sin cube t 0 to pi over 4, which is negative 250 over 3 sin t. Sin pi by 4 is 1 over root 2 cube minus sin 0 is 0. So minus 250 over 3. This can be written as 1 over root 2 square is 2, again a root 2. This is a 2 root 2. So 2 can be cancelled, the numerator you will get negative 125 negative 125 divided by 3 root 2. That's the end. You can stop here. That's the end of the first case of the first problem. Now there are 2 more cases in the first problem, isn't it? What is next? Case 2. This one we are going to do. Integral over c g of x y dy, and dy should be found from here. Dy is 5, integral differential of sin t is cosine t, isn't it? Now substitute everything. Integral 0 to pi over 4, 2 times 5 cosine t, 5 sin t is y, and dy is 5 cosine t again. isn't it? So dt and finally dt. There is a dt here. Okay, now club the constants together. It will be 125 into 250 is constant. This time it is positive. Now again, now you get cosine square t sine t dt. Hereafter I think you can integrate it. You want me to integrate? Let u is equal to cosine t. Therefore du is equal to minus sine t dt. There is no minus here, so minus comes out, isn't it? So it is 250 integral 0 to pi over 4 cosine square is u square minus du. This is negative, now du. Not here, the answer is different because u is not same. Minus 250 into u cube over 3 from 0 to pi by 4. So we can use here minus 250 over 3. U is cosine cube t in 0 to pi by 4. Okay. So minus 250 over 3 cosine pi by 4 is still 1 over root 2 whole cube minus cosine 0 is 1. That's the difference. So minus 250 over 3, this is 1 over 2 root 2 minus 1. Stop here. If you want, you can simplify further. That's secondary, right? You can stop here. So this is different from the previous one. Third is about ds. This one with respect to ds, and you should know what is ds. Root of f dash of t whole square g dash of t whole square times dt. This x is f of t, isn't it? Y is g of t. So we have to find x dash and y dash squares. So what is x dash? F dash of t, pi times minus sine t whole square. Square will do later. G dash of t is phi cosine t. Therefore ds square root of negative phi sine t whole square phi cosine t whole square times dt. So this is phi square under square root will be phi outside. So this is sine square t plus cosine square t dt, and you will get this term as phi dt. Okay, so ds is phi times dt. We got it. And now we have to expand the formula. Integral g of x comma y ds along c is, for the problem number 1 we are doing, isn't it? Problem number 2 is not in parametric form, which is in implicit form, isn't it? Implicit form. Okay. Okay, function is in implicit form, and now we have to finish this one fast, and then here y is given explicitly. Okay, that's okay. That's not a problem. We are solving problem number 1. Third part. What is it? ds. So to integral 0 to pi over 4 the limits of t, and 2 times x 5 cosine t 5 sine t, and ds is 5 dt. So what appears next is 5 120 into 250 integral 0 to pi by 4 sin t. Okay, you can write 125. There is a reason why. If I multiply 555, I write 125 integral 0 to pi by 4 2 times cosine t sin t. I will write sin 2t dt. You can find from the identities of trigonometry that 2 sin theta cosine theta is sin 2 theta. So it is easy to use this identity. Therefore what you end up is 125 integration of sin 2 dt cosine 2t over 2. This should be negative cosine 2t 0 to pi by 4. So what happens next is 125 negative 1 by 2 outside cosine 2t cosine 2 times pi by 4 cosine 90 is 0 minus cosine 0 is 1, so which is negative 1 into this one 125 over 2. That's the end of this problem. So problem number 1 has been solved in all the 3 cases. Let's try problem number 3. Again all the 3 cases dx, dy and ds, isn't it? Dx is quite easy. Dx, just substitute those values and we'll get the answer. 3, first case a for 3, isn't it? Integral c g of x comma y dx. See, we are given an implicit function y, not a parametric form. Sorry, this is explicit function, not implicit function. Implicit means it should be defined x square plus y. So this one is an example of implicit function, right? Here y is a function of x, which is explicit form, right? Now when y is given as explicit function and the relation between y and x is given here, right? Not a parametric form. So you got to replace y values everywhere. The limit of x is given, so we are integrating from negative 1 to 0. Everything is going to be in x. 3x square plus 6y square. What is y? 2x plus 1 whole square. Now 3x square. Then finally dx is given as dx. First case goes with the dx, isn't it? So now simplify and integrate it. Negative 1 to 0, 3x square plus 6, and to expand this one 4x square plus 4x plus 1 dx is common. The integration I leave it to you because it's straight away an integration that you have been doing since calculus 2, isn't it? And answer here for the case is 3. You try just all algebraic terms, direct integration, the answer is 3. There is nothing to worry in this case, isn't it? Try this one. I'm going for second case, dy. What happens here? Y is given as 2x plus 1. So what is dy? When you differentiate both sides, it will be dy. The left side will be 2 times dx. 2 times dx plus 0. So integral part b, we are integral over c g of x comma y dy is limit is negative 1 to 0 x. First time is 3x square and y square 6 times 2x plus 1 whole square, and dy is 2 times dx. That's all. Just like the previous integration, only 2 is in front of it. So minus 1 to 0, 3x square plus 6 times 4x square plus 4x plus 1, 4x square, 4x plus 1, isn't it? Everything is like previous integral term. The only thing is there is a 2 in front. So 2 times 3, the answer is 6. Because the previous answer is 3, this term will lead to 3. The answer is 6. And now the final one, ds. ds, the relation when it is given as y, ds is square root of 1 plus y dash square dx. Isn't it? So what is y dash here? Y is 2x plus 1. So y dash is differentiation with respect to x is 2. So 1 some problem. Let's see. 1 plus 2 square is 4 dx. Therefore ds is equal to root 5 times dx. So what we are going to do, everything to be converted into so remember, for case C3, third problem, third case, ds we have found, which is root 5 times dx. So refer back the formula when you are getting explicit function defined by explicitly. So ds is 1 plus f dash square, that is y is y dash square, y is equal to f of x, isn't it? So f dash is y dash and times dx, that is ds. That's what we are going when a function defined explicitly instead of parametric form. Okay, now this term integral over c g of x y ds can be written as 0 negative 1 to 0 same term 3x square plus 6y square y 6y square 2x plus 1 whole square dx. But dx, this is root 5 times dx. Okay, now you take root 5 outside, square root of 5, negative 1 to 0, 3x square plus 6 times 4x square plus 4x plus 1 dx. This integration from the first result, it is known as 3. So root 5 times 3 root 5 is the answer. You verify this integration is 3 or not in the first case. That is it. Now let's go to the next kind of problem. For 3 variables, g of x comma y comma z, for 3 variable case. Let's try this one. So big one. There are 4 integrals to be done. One with respect to x, with respect to y, with respect to z, and then ds. ds is x dash, that is x dash square. I can write f dash square, g dash square, h dash square dt. X, and remember x is f of x, f of t, y is equal to g of t, z is equal to h of t. So this is your f, this is your g, this is h, and t is given from 0 to 1. Let's do the first one. Integral case A, integral g of x y z dx is, the limit of t is 0 to 1, and substitute the x value 4 times x y z. This is z of x y. X is given here, y is given here, z is given here. Substitute them. 4 times 1 by 3 t cube, y is t square, z is t2, and dx, find dx from x. Dx is 1 by 3 t square dt. So it is t square dt. Simplify. What do we get? 4 to 8 over 3. 8 over 3 integral 0 to 1. What is the degree of t? T square, t power 5, t power 3, 5, 8. t raised to 8 dt. So it will be 8 over 3 t raised to 9 over 9, isn't it? From 0 to 1. So 8 over 9 into 3, 27. T is replaced by 1, it will be 1 minus 0. So the answer is 8 over 27. First is done. Second case B, I am doing here integral g of x y z dy. Integral 0 to 1, the same, 4 times 1 by 3 t cube is for x, y is t square, z is 2t, and dy can be found from here. Y is equal to t square, so dy is 2t dt. Now simplify. Integral 0 to 1, how many, what's the constant? 4 into 2 into 2, 16 over 3. 16 over 3 is constant. T cube, t to the power 5, 6, 7, t to the power 7 dt. So 16 over 3, t raised to 8 over 8. When you integrate, the degree will increase from 0 to 1. So 16 and 8 can be cancelled, it will be 2 over 3 and 1 minus 0. So the answer is 2 over 3. Two cases have been done. Third case is with respect to z. So when you with respect to z, then what is dz? It is 2 times dt. Just substitute case C. Integral 0 to 1 4xy, 4 times 1 over 3 t cube, y is t square, z is 2t, and dz is, we are doing this one, dz is 2 dt. So simplify, constant 2 to 4 into 4, 16 over 3, 0 to 1, t is cube, t to the power 5, 6, t to the power 6 dt. So 16 over 3, t to the power 7 over 7 from 0 to 1. 16 over 3, and 3 into 7 is 21, 1 minus 0. So 16 over 21. All the integrals give you different answers. Now find fourth case with respect to 0 to 1, the same, 4 times 1 over 3 t cube, t square for y, z is 2t. Now ds, find ds here. First derivative, x, differentiate x, 1 by 3. So first I am finding here f dash of t, which is 1 by 3 into 3 t square, which is t square dt. G dash of t, second, 2t dt. H dash of t, third time, 2t. When you differentiate 2t, it will be 2 dt. So it will be t square plus t square whole square, t raised to 4, because f ds is f dash square, g dash square, h dash square times dt. So what is ds? F dash square, t raised to 4, g dash square, 4t square, h dash square, 4 outside dt. Now simplify ds further. I write it here. Here I write ds under square root, you can write t square plus 2 whole square. Expand it. it will be t raised to 4, 4t square plus 4, isn't it? Now and take square root, ds is equal to t square plus 2 dt. So we will write ds here instead of ds, t square plus 2 dt. Now the constant 2 into 4, 8 over 3 integral 0 to 1 t power 3, 5, 6 t power 6 into t square plus 2 dt. Now we have to multiply this one inside, that is 8 over 3 integral 0 to 1 t raised to 8 plus 2 t power 6 dt. And this integration can be further done the next page. I will do one thing, I erase this page. So integration 8 over 3 integral 0 to 1 t to the power 8 plus 2 t to the power 6 dt can be written as t power 9 over 9 plus 2 t power 7 over 7 from 0 to 1. The constant outside is 8 over 3. So 8 over 3, this is 1 over 9 plus 2 over 7 upper limit, minus t is 0 gives 0 for all. So simplify this one, you get 200 over 189. That's the end of this problem. And now evaluate this integration. There are two problems, problem number 8 and 10. Evaluate this integrals. Integral p dx q dy, p dx q dy, isn't it? First part with respect to x, second part with y. On the given curve, first curve is y is equal to x square plus 1, explicit form, isn't it? So what is dy? Dy is 2x plus 0. And from this points you find the limit of x is -1 to 2. If you want limit of y, it is 2 to 5. I will integrate here, integral over c. I am converting everything into x. So the limit of x from this one is, from the lower point limit is -1, upper point limit is 2. So -1 to 2, everything is in x. 2x plus y, what is y? Y is equal to x square plus 1. Y is equal to x square plus 1. X square plus 1 times dx plus x into y, xy, x into y, y is x square plus 1 dy, dy is given here 2x dx, isn't it? 2x dx, 2x dx. Now simplify all. It will be -1 to 2, here 2x x square, here it will be x cube, this is 2x plus y dx, isn't it? Here there is an x, so simplify everything. 2x plus x square plus 1, here there is a 2x and x and x, 2x power 4 plus 2x square, 2x and x square, all together there is a dx. Now further simplify, first term highest degree is 2 power x power 4, then this x square will be 3x square and plus 2x plus 1 dx. Now term by term integrate it. First term will be 2x power 5 over 5. So integration is from -1 to 2. Second term will be 3x cube over 3. Third term will be 2x square over 2. final term is x from minus 1 to 2. Now you know 3 will be cancelled, 2 will be cancelled. Substitute upper limit 2. The first term 2 into 2 power 5 divided by 5, 2 cube, 2 square, 2, upper limit minus 1. So this is minus 2 by 5 minus 1 plus 1 minus 1. Use calculator, you find 141/5. That's it. That's the end of first problem. Problem number 8. Problem 10 is yet to be started. Problem number 8 is done. Problem number 10 is looking different, isn't it? We have not been given any function. This is 3 smooth curves. This is smooth curve 1, smooth curve 2, smooth curve 3. So we have to find integrals along 3 different smooth curves and then sum them up for the same integration. C is C1, C2 and C3, right? Okay. Along C1 we'll write some information. Along C1, what is happening? First I will find integration along C1. So along integration along C gives integration along C1 plus integration along C2, integration along C3. First so this is equation number 1. We want to integrate along C. This is our integral. C is the curve. It has been separated by 3 smooth curves. So first one is along C1. We have to collect some information. C1 is the line parallel to y-axis, which is x is constant, x is negative 1. Along this line, x is negative 1. This x is constant will give you dx is 0. And throughout this line, y varies from 2 to 0. So integration limit can be done with respect to y because dx is 0. Let us do it along C1, which is integral y 2 to 0. Isn't it? And what is 2x? X value is negative 1. So 2 into minus 1. Y is the variable now. Dx is 0 along because this line is parallel to y-axis. X is constant, so dx is 0. And x is negative 1. Y is variable dy. First term is 0, second term is minus integral y dy from 2 to 0. 2 to 0. What is the answer? So the answer is negative y square over 2 from 2 to 0 minus outside 0 minus 4 over 2. The answer is 2. So along C1, remember this answer is 2. Now we have to find along C2 and along C3. 2 more curves, we will add them at the end, right? So I will find along C3, C2 along the curve C2. What are the, see, this is your curve C2, x-axis. So y is 0. Obviously dy is 0. So second part will be 0. Y is 0, dy is 0. So this part is 0. What happens? What is the limit of x? X is from negative 1 to 2. X varies from negative 1 to 2. Therefore, integral along C2 is integral x is from negative 1 to 2. Here, 2x plus 0, y is 0 given here, right? 2x times dx, which is 2x square over 2 from minus 1 to 2. So 2 can be cancelled. X square is 2 square is 4 minus 1 is 3. So along C2 the answer is 3, second, and first answer is 2, second answer is 3. This is the connection. Now let us do for along third curve. Now you got an idea, I think. Along C3 is this line parallel to y-axis. X is constant. See, x is starting at 2 and here ending also 2. Throughout this line x is 2. Therefore dx, x is constant, the derivation of x is 0, and y varies from 0 to 5. Check, here y is 0 and here y is 5. So integration is with respect to y. Dx is 0, this part will be 0. So along C3, what do you get? Integration 0 to 5. First part is 0. Second part x is 2, y is variable. 2y dy. 2y square over 2 from 0 to 5. 2 can be cancelled. Y square is 25 minus 0. So the answer is 25. So along C3 the answer is 25. So integration along C is integration along C1, along C2, along C3, which is first answer is 2, second answer is 3, third answer is 25, the answer is 30. Final answer is 30. Now similar type question you have to do for this is the integration y dx given curve C between 0 and 1 1. C consists of 3 line segments. What are they? 0 0 is origin and 1 0 is on x-axis, isn't it? And from 1 0 to 1 1, 0 0 to 1 0, first line segment we call it C1. Second line segment from 1 0 to 1 0 to 1 1, 1 1 will be here, both side 1, isn't it? 1 1. So this is the second line segment, called it C2. So C1 plus C2. Integration over C should be written as integral over C1 over C2. And I give some properties along C1, this line. Y is 0 gives dy is also 0. So y is 0, dy is 0, both of terms should be 0. So y is 0, there is the first term, y is 0, dy is 0, second term, so entire integration about C1 is 0, first equation. Along C2, this line, okay, x is fixed as 1 because here x is 1, here also x is 1. So x is 1 gives dx is 0 and y varies from 0 to 1. Here y value is 0, here y value is 1, that is 0 to 1. Therefore the integral dx is 0, first term is 0, isn't it? Integral over C2, first term is 0, second term integral x, y is 0 to 1, x value is 1, dy, which is y from 1 to 0 to 1, which is 1. Therefore the answer is 0 plus 1, the answer is 1. I have done it. See, from the point, another information for you, in the previous problem, I would like to give a hint to the next chapter. When this is our x is negative 1, here x is 2, here y is 2, here y is 2. From negative 1 to this point, negative 1 comma 2 to 2 to 5, there are many paths. One path is this one. The integration answer, answer is 30. There is a direct answer. If you go with this straight line, there is an equation of straight line y is equal to some. You can find by using the end points of the line. You can find the equation of the straight line is something x plus 3 something, isn't it? Okay, there is another possibility to integrate this way. The answer will be different. And if you draw a parabola this way, you can call this is the parabola. This goes this way, from this point to this way, and the answer in this case is totally different. Isn't it? The first case, the answer was around 141 divided by 5, which is not near to 30. So what I am coming to say, there is a point A and there is a point B. From A to B there are infinitely many curves. Along every curve the answer is different. If in some cases, if all the integrations along every curve from A to B are same, it means that the answer is depending on the end points, not the curves. Such case is our next chapter called independent of the path. It is not depending on the path, it is depending on the end points. When integration along every curve is same, giving you the same answer. So in such cases, the function is called, the integration is called path independent. Right? Let's see the next chapter. Okay, this chapter has not been done yet. We have to again integrate this one along the closed curve C. Closed curve, this is, take this two piecewise curves. This is C1, another one is C2. This entire curve is C2. Okay. Along C1, as usual, along C1 it is x-axis, so y is 0, dy is 0. This part will be 0 and this part will be 0. So integral over C x square dx. And the radius of the circle is 2, because this is r square is 4r is 2, isn't it? So this is 2 units in x, negative 2 units here. So the limit of x will be negative 2 to x square dx. What you get here is, this is a trivial one. Integrate x square, you will get x cube over 3 and substitute lower and upper limits. X cube over 3 from negative 2 to positive 2. 1 by 3, 2 cube is 8 minus 2 cube is minus 8. So 8 plus 8, 16 over 3. When you integrate along C1, the answer is, so I write it here. Integration over C1 is 16 over 3. Now another curve is C2, this one. It is a circle. You can write in parametric form. The radius is 2. So we can write this circle is x is equal to 2 cosine t and y is equal to 2 sine t. So we will do it for along C2. Remember, integration along C1 is 16 over 3. Now our integration is along this curve. This is a circle, so which is of radius 2. So x is equal to 2 cosine t and y is equal to 2 sine t. Is the parametric form. And since this circle is semi, and we can write everything in theta, not theta angle. Angle is from theta is from 0 to pi, not a full circle, semicircle, isn't it? What is dx? 2. When you differentiate 2 cosine theta, you will get 2 minus sine theta d theta. What is dy? Differentiate this one. 2 cosine theta and d theta. Right? Now use everything in integral over C2. Integral theta will be 0 to pi. First, x square plus y square is equal to 4. dx is given here, minus 2 sine theta. X square is y square given here, right? Don't worry. Minus 2 sine theta. Theta first term plus second term is minus minus 2xy. X is 2 cosine theta, y is 2 sin theta, and dy is 2 cosine theta d theta. So we got to simplify further. Integral 0 to pi. First d theta is a common term, isn't it? We can take outside. The first term minus 8 sin theta minus 8 sin theta. Here 2 into 2 into 2, 2. What is it? 2 into 2, 4 into 4, 16. 16 cosine square theta into sin theta. Now take d theta outside. Again you can take common terms, minus 8 outside, 0 to pi, sin theta outside, minus 8 sin theta outside, though this will be 1 plus 2 cosine square theta d theta. Now substitution method to be used. Let x is equal to cosine theta gives dx is equal to minus sin theta d theta. This minus sign with the sin theta d theta will be dx. Therefore the integration becomes, maybe now I have to check whether this is still recording or not. Okay, dx is equal to, now this integration becomes minus a, so this integration will become minus 8 will be outside, integral 0 to pi, this will be 1 plus 2x square into dx, because this minus sin theta d theta will be dx, 1 plus 2x square, x is cosine theta. Now integrate it, x is 8 is outside, x plus 2x cube over 3 from 0 to pi, and replace x as cosine theta, 8 cosine theta plus 2 cosine cube theta divided by 3 from 0 to pi. So what do you get in further? 8 will be outside, cosine pi is 0 plus cosine pi is, okay, cosine pi is minus 1, not sin pi is 0, as cosine pi is minus 1, cosine pi is minus, cosine cube pi is also minus, so minus 2 by 3, and this is 0. This is for upper limit, minus cosine 0 is 1 plus 2 by 3. Simplify all these things, you will get minus 80 over 3. This is pi, minus 1 minus 2 by 3, okay, minus 1 plus 2 over 3. Simplify, it will be 80 over 3. So integration over C2 is minus 80 over 3. Therefore the sum of this one is called integral C over C. What is it? Minus 80 over 3 plus 16 over 3, it will be minus 64 over 3 is the answer of this problem. Let's end. Then the next problem is problem number 8. I think 2 more problems. Yes, 2 more problems to conclude. integration of this one, isn't it? F dot dr. See, when r is simply x I y j, we don't have a problem. But when x is a function of x, function of t, y is g of t, we should replace wherever x comes exactly. So it gives a parametric form of the line, isn't it? So what is from this one? This is r. From r we get x is xi. This is xi yj. X is e raised to minus 2t. Y is e raised to t. This is important information. Comparing the original form of r with the given. So x is e raised to minus 2t y. Now we got the parametric form, isn't it? Now f of f dot dr. Let's find f dot dr. Substitute x, y in f. What is y cube e raised to t whole cube I minus x square e raised to minus t whole square into y e raised to t j. This is f now. Substitute x and y here. Dot dr vector. Dr, differentiate r. R has been given here, isn't it? R has been given here. Find dr vector. Differentiate e power minus 2t. This is e power minus 2t into minus 2i plus e power t j. This is dr. So we will write dr here. Minus 2 e power minus 2t I plus e power t j. And you know dot product of two vectors. So f dot dr will be this term will be I and I will be 1. So e power 3t minus 2 into e power minus 2t. That's the first term. Minus this one e power minus 4t e power t, and here that is e power t. Second term, when you simplify further, it will be, the power should be added. 3t minus 2t is t minus 2 e power t minus e power minus e power, and you remember in the while finding dr there will be dt because it is dx and dy times dt. That dt should not be forgotten, it will be here, it will come along with this one dt. Okay, at the end there will be dt because this is dx and dy and j times dt. Okay, this is minus 4 plus 1 plus 1 minus 2t dt. That's the dt should not be forgotten. Now integrate. Integral over c f dot dr is equal to integral over c. What is the limit of t? T is 0 to ln2, 0 to ln2 minus 2 e power t minus e power minus 2t dt. So in the next step we will integrate it. Minus 2 is constant, e power t remains e power t minus e power minus 2t divided by minus 2. It will be positive, isn't it? From 0 to ln2. So in the next step, what you get is this term. You should remember. We will write next step. So integral cf dot dr is equal to minus 2 e power t plus 1 over 2 e raised to minus 2t from 0 to ln2, wherever t comes replace it by ln2 minus 2 e raised to ln2 plus e raised to minus 2 ln2 divided by 2. This is for upper limit. Now lower limit is 0. Minus 2 e power 0 plus 1 by 2 e power 0. E power ln2 is 2 minus 4. This one is e power ln x is equal to x. So this will be 2 into minus 2 will be minus 4. Plus this will be square here, 2 square. So e minus, so minus 2 ln 2 is ln 2 power minus 2. What is it? ln 1 by 2 square, 1 by 4. So this will be e raised to ln 1 by 4. So 1 by 4. 1 by 4 divided by 2 minus 2 into minus 2 plus 1 by 2. This is 1 over 8, isn't it? Minus 4 plus 1 over 8 minus 4 plus 1 by 2. Minus 32 plus 1. Minus 31 by 8 is the first term, minus 3 by 2. And the answer is minus 19 over 8. End of this problem. The last problem. So the same task we have to do for 3 curves. There are 3 curves here. Find the work done by the force. Now work done by the force, an important question. Acting counterclockwise once around the triangle with vertices. So we should be alert about the vertices. And we need to find r vector for every straight line, isn't it? Because f dot r, we know work done is nothing but f dot r. So we need position vector and then differentiate it to get first to find r vector and then differentiate it to get dr vector. Take dot product with f, integrate it for every. This should be done along every curve, c1, c2, c3. Let's see how many curves are there. Okay. On the xy line, the triangle is given 1 1. This is 1, this is 1, here 1 1, and x is 1 2 3 3 here. So this is 3 comma 1 second point, isn't it? And 3 comma 2 3, y is 2 1. The third point will be here. This is 1 1, this is 3 1, this is 3 2. So there are 3 line segments. This is can be 1, this can be c2, and this can be c3, anti-clockwise. This is the positive direction of the integration. Now we take some vectors, we find the position vector. We want to find actually r vector is xi plus yj, isn't it? X and y in parametric form you can find. Use calculus 3 to write the parametric form of the vectors. X is x0 plus at, y is y0 plus bt, y parametric form of the straight line, isn't it? You can find x and y and then use here. That is one method. So here you can find a vector for joining these 2 points minus 1 1 and 3 1, which is passing through one point. So if you have one vector and a point, you can find x and y. Otherwise, simply here you will write in the direction of I. First I am writing r1 vector for c1 along c1, isn't it? I want r1 vector. So what I am doing, in the direction of I, there is a change in 2 units. So here 1 is 2, isn't it? So I am writing 2 units. In the direction of I, it is 2 units, and in the direction of j, no change. So how to write the vector? 1, the starting point is 1 of x, so 1 plus 2 times t. See, t is given as t. It is better to choose t between 0 and 1, isn't it? T it is between 0 and 1. Maximum value of t is 1. So p1 will give you x is 3. Plus in the direction of y, no change. So 1 height remains 1. So 1 unit j. This is your R1. If you have confusion with this one, you can go ahead with this one. You can find the y is in calculus 3. That is the concept of finding parametric form of a straight line when you know that there is a point x0, y0 and a vector parallel to it, b vector, which is a comma b, isn't it? Here you can find the vector by using end points, and one of the point a or b can be chosen for x0, y0. You can find x and y, then write r. Still it will be same. Okay. And what I am doing for r f vector now, dr1 different. This is 1 plus 2t I direction. Starting is 1, 2t, 2 is the difference between 1 and 3, so 1 plus 2t I. There is no change in j, isn't it? This is so dr1 is differentiate this one. What do you get? When you differentiate, 1 is 0, 2t becomes 2i, that's all. So f vector dot dr1 vector f vector is x plus 2y I plus 6y minus 2x j dot with the 2i. So only I command will go. So the answer is 2 times x plus 2y. 2 times x plus 2y, and x and y should be found from r1. R gives you x is 1 plus 2t and y is 1. So let's integrate this one first, and then you can do the same task for other parts for C2 and C3, and then sum all the results, right? So when x is substituted here, so I am doing this one here, integral over C1 is integral t should be 0 to 1, assuming that t is 0 to 1, because when t is 0 you will get x is the beginning position, t is 1 you will get x in the end position. This is the rule. So 0 to 1, x is 1 plus 2t, 1 plus 2t plus 2 times y is 2. And there is a 2 outside. dt Now what we get is integral 0 to 1 multiply this 2 plus 1 is 3 into 2 6 plus 4t dt. You will get the answers. So I will integrate in a separate sheet. The integration over C1, that is f dot dr1 is equal to integral 2 times 1 plus 2t plus 2 dt. So what do you get? 2 on 3 into 2 6 plus 4t, it is 0 to 1, get 1 dt. 6t plus 4t square over 2 from 0 to 1, it is 6 plus 2 minus 0, 8, and the answer is 8. So minus, it is 0, lower limit is 0 for all, so the answer is 8 for the first case. In the similar way we have to do for C2 and then C3, sum the answers. Finally sum answers. For along C2, what is R vector? You check, and I am writing here R vector. Then R2, take it R2 is 3i, there is no change in I, both remains change, x remains change, check the graph. And 1 unit change in y, 1 plus 1 time t j. This will help you, and then differentiate it. You will get dr2t and dt. Dot product with the f, integrate from 0 to 1. Okay. And for C3, what is R3 vector? C3 from C to A, isn't it? C to A, it is coming from the point 3, 2. In this triangle, this is 3, 2, and this is 1, 1. So you are coming this way from 3 minus 2. So 3 minus 2t for x direction plus 2 minus 1. So 2 minus 1 plus 2 minus 1 time t j, where t limit is 0 to 1. And then find dr3, then dot product with the f, and then integrate from 0 to 1. You will get 3 answers, sum them up, and the final answer is -4. Final answer is -4. Try. If you don't find, if you have doubts, let us discuss in the classroom, next classroom. Okay. Thank you very much for your question. This is the last problem of this session. This one will be in the next video. Thank you.